So to better understand the computation of prestress loss due to shrinkage, let us apply it in a sample problem. So this is the sample problem. A prestress beam has a span of 15.2 meters or 50 feet as shown. So this is the prestress beam with a harp tendon, simply supported beam, supporting a uniformly distributed load. Compute the loss in prestress for pre and post tension case. So we will solve the loss of prestress using pre-tension and post tension case. So compute for the loss in prestress due to shrinkage at 7 days after moist curing. After moist curing using both the ACI-ASE method and the time-dependent method. Assume that prior to transfer, the jacking force on the tendon was 0.75 FPU and that the relative humidity is 70% and the volume to surface ratio is just equal to 50 mm. So it is there is a specific magnitude of ultimate shrinkage strain that is specified on the problem, uh, which recommends to use the ultimate shrinkage strain specified on ACI 209 or the 08 section 8.1.1. So the other information about the problem are this: for the cross section at midspan, it looks something like this with dimensions equal to this, and the distance of the pre-stressing reinforcement to the bottom of the concrete beam equal to this. Other parameters given are FC prime, FCI prime, FPU, APS, and then EPS. So those are the other parameters given. The FC prime, which is the compressive strength at 28 day, FCI prime, which is the compressive strength at transfer, the ultimate strength of the pre-stressing reinforcement, the area of the pre-stressing reinforcement, and the modulus of elasticity of the pre-stressing reinforcement. So without further ado, let's compute for the pre-stress loss due to shrinkage for the case of pre-tension members first using ACI-ASE method. So if you will try to recall the formula for the adjusted shrinkage strain using ACI-ASE method, uh, the formula is equal to this. So we have to find the magnitude of KSH, V over S, and RH for us to be able to solve this equation here. So for the case of KSH, we know, if you can remember from the previous discussion a while ago, that for the case of pretension members, KSH is just equal to 1. And then V over S is just given on the problem, the volume to surface ratio, which is equal to 50 mm, as well as the relative humidity, which is equal to 70%. So therefore, we just have to substitute them on this equation, and then we can already compute for the adjusted shrinkage strain that will be used on this equation to find the pre-stress loss due to shrinkage. So substituting all of those on this equation, EPS is equal to 186,200. Shrinkage strain is equal to this. So you just have to substitute all of the corresponding values. KSH is equal to 1. V over S equals to 50 mm. RH is equal to 70. So you have to take note that RH must be in terms of percent. And again, since this is unitless, the magnitude of the units of the pre-stress loss due to shrinkage will be coming from the modulus of elasticity, which is expressed in terms of megapascal. So we can expect that the pre-stress loss due to shrinkage that we will be that we can compute here will just be in terms of megapascal. So computing the equation here, we can see that the pre-stress loss due to shrinkage for pretension members using the ACI-ASE method will be anticipated to be equal to 40.309 megapascal. So meaning for the case of pretension members, after the shrinkage already occurred on the concrete, will will eventually result to loss of pre-stress to the pre-stressing reinforcement. We can anticipate that that magnitude of loss that will be experienced by the pre-stressing reinforcement will be equal to 40.309 megapascal. So for the case of post-tension members, again, still using the ACIAC method, we just have to change the magnitude of KSH since we have a different value of KSH for post-tension members specified on PCI, the Prestress Concrete Institute. So since it was mentioned here that shrinkage, the loss in pre-stress due to shrinkage must be computed at 7 days after moist curing. So we have to use the corresponding KSH 7 days after moist curing, which is equal to this 0.77. So and then we just have to substitute that again on this equation in order for us to find the pre-stress loss due to shrinkage for post-tension members. So we just copied the previous equation. We just change the magnitude of KSH from 1 to 0.77. So you can see here that the the shrinkage strain, the adjusted shrinkage strain for post-tension members uh, is usually uh, used as less than the uh, the shrinkage strain for the case of pretension members, because for the case of pretension members 100% of the shrinkage strain is used. If you can use if you can see on this magnitude of KSH. But for the case of post-tension members, as you can see here, all of the values are all less than 1, meaning the shrinkage strain for post-tension members is usually just a percentage of the shrinkage strain for the case of retention members. That's why the pre-stress loss for post-tension members are usually less than compared to the case of retention members. So if we will compute this equation, we can see that the pre-stress loss that will be experienced by the pre-stressing reinforcement because of the occurrence of shrinkage on the concrete will be equal to this magnitude here, 31.038 megapascal, which is obviously less than the one we computed for the pre-tension members, which actually proves the statement we said a while ago, which says that the pre-stress loss for post-tension members are usually less than the pre-stress loss being experienced uh, by the pre-stressing reinforcement for the case of pre-tension members due to shrinkage of concrete. So it is proven here on our actual computation. So that is only for the case of using the ACI-ASC method for the pre-tension and post-tension case. So now let's move on to the other method, which is the time-dependent method. So if you can recall the formula for the adjusted shrinkage strain for time using the time-dependent method for moist cured concrete at any time T after age 7 days, because it was specified on the problem that we have to use 7 days after moist curing. So we must use the case of moist curing for us to be able to solve for the adjusted shrinkage strain using the time dependent method. So if you can recall the formula for moist cured concrete at any time T after age 7 days, it is equal to this. So for the case of for the value of the ultimate shrinkage strain, we can use the one specified on ACI 209R-08 section A1 A.1.1, which is equal to this. So again, you have to remember the recommended value that we have said a while ago must be used only if there is no given value on the problem, or if the local data is not already available. But since it was already specified on the problem that you have to use the ultimate shrinkage strain specified on ACI 209R-08 section 8.1.1, so you have to use that magnitude of ultimate shrinkage strain for the computation of the adjusted shrinkage strain that will be used to compute the loss of pre-stress due to shrinkage. So Again, using the same formula for the computation of pre-stress loss, with just having a different magnitude of adjusted shrinkage strain that will be used here, we can just substitute all of the corresponding formulas on this equation here. So again, EPS is specified already on the problem, and then the adjusted shrinkage strain is equal to this, wherein T is equal to 7 days according to the problem, and then multiplied by the ultimate shrinkage strain specified by the problem, which is equal to this. So the answer will be 24.206 megapascal. Or is that really the answer? Is this really the correct answer for the computation of the pre-stress loss due to shrinkage for this particular problem? So actually, that is not the final answer. So you have to be cautious with that. So why is this not the final answer here? So you have to take note that these formulas that we have specified a while ago is just for standard conditions of relative humidity, which is approximately equal to 40%. But on this particular problem, it was specified that the relative humidity is 70%. So we have to adjust this value that we have computed here. We must multiply it by the correction factor specified a while ago. And the correction factor that will be applied for this case, since it has a relative humidity that has a magnitude between 40 and 80 inclusive. So we must use this formula here for us to be able to correct or to account the the different factors for other values of humidity. So we just have to multiply this to the adjusted shrinkage strain that we have computed a while ago. Or simply we can just multiply this value we computed a while ago by this correction factor here. So substituting the magnitude of H, which is equal to 70 again, always express H in terms of percent. Therefore, we can solve for the adjusted, or I mean, we can solve for the actual or estimated pre-stress loss due to shrinkage, which is equal to this. So actually, on the on the formulas we have given, it is not specified that the formulas given a while ago for the case of time-dependent method uh, is used for pretension or post-tension case only. So we can assume that the formulas given a while ago is applicable for pretension and post-tension cases. So again, that is the magnitude of the anticipated loss due to the occurrence of shrinkage on the concrete. So this is the anticipated magnitude of the pre-stress loss that will be experienced by the pre-stressing reinforcement as the concrete experiences what we call shrinkage.